Hello everybody, so today's topic is microclimates, as is appearing on screen in front of your very eyes. And the year that I'm making this video, the module booklet pages that accompany this are page 60 onwards, 60 onwards. Okay, now a few lessons ago, we usually teach this in the cool western temperate maritime section of the module. We talk about the difference between climate and weather, and the essential difference between those two is a time scale thing. So weather is short term, it's what's going on in the atmosphere right here, right now, whereas climate is the 30-year average. You work out what kind of weather that place gets in January over a 30-year period, and that's what the climate is. Okay, so micro means small, and what we're studying here is the idea that you can have a climate, for example the cool western temperate maritime. We already know that there will be regional variations, i.e. the west of the UK is wetter, the north of the UK is cooler, that sort of stuff. We're now going to small scale, going micro. All right, and it's the idea that for a whole host of different factors, a tiny little area might have slightly different conditions. Pretty straightforward idea. We looked at aspect already, and to be honest, aspect is one example of microclimate. Here we have a valley. This valley is facing the North Pole. This is facing the equator. And you can see that because the north-facing slope doesn't receive any direct sunlight, it is clearly much colder than the south-facing slope. And in a residential area, it might have that kind of effect. You may have noticed that if you do ever get snow where you live, that it tends to melt more quickly on one side of the road or one particular place where you live than it does in others. And that's probably to do with microclimate. Some of you might have done your coursework on the microclimate of woodlands. Because the trees block out the light, you can have very different climatic conditions within a woodland than you would on the in the fields and surrounding areas. They're generally less windy, they are quite humid, there's not as much sunlight, they're cooler, that sort of thing. But the only one that you have to know for this module are urban microclimates. And I chose that photo just because I thought it was really cool. Maybe a bit of bright colour to cheer us up on a gloomy January day. So we only need to know urban microclimates, and everything I'm going to talk to you about for the rest of this video is going to focus on them. Okay, now on page 60 you've got a table with a whole load of facts and figures about how urban areas are different in terms of their microclimate. The three on screen right now are the only ones that you need to really remember. Urban areas are hotter, less windy and wetter. And what I'm going to try to explain to you today is why. Why is that? So maybe highlight those, asterisk them, draw attention to them in some way. The others you don't necessarily need to remember. I mean, be my guest, but you really don't need to commit them to memory at all. Right, the fact that urban areas are hotter has a name. An urban heat island, or UHI. You know how geography loves an acronym. So urban heat islands, UHI. And the idea is quite simply that urban areas are hotter, and you can represent that in a sort of cartoonish way. For some reason that diagram always makes me think of The Simpsons. You can represent it as a line graph, you can represent it as an isoline map, you can get a bit funky with electronics, you can do a heat map, you can do all sorts of things, okay? So urban heat islands are often represented in a whole host of different ways. But why? That is the $64,000 question, ladies and gents, and you've got the answers to this at the bottom of page 61. What I want to do is I want to go through those bullet points and make sure that you understand them. Why are urban areas hotter? Okay, Sorry about the use of the word stuff there. You can personalise that however you want. Urban areas have more people. People release body heat. Urban areas have more cars. They release more heat. There are more businesses with either heating systems or air conditioning. To cool the shop or the office down, the heat gets pumped outside. You might have more factories. You're going to have all sorts of things that are producing heat, and that's purely because you have more of all that stuff in urban areas. Secondly, we have our good old friend albedo, which we talked about back in the beginning of the module. Albedo is linked to the colour of surfaces. Pale coloured surfaces tend to reflect heat really effectively, whereas darker coloured surfaces tend to absorb it. Most urban areas tend to have quite a lot of dark surfaces. Tarmac, for example, roofs are often quite dark, that sort of thing. So we've got a lot of dark colour surfaces. But we also have a lot of shiny things. That doesn't sound very academic at all, does it? We have a lot of glasswork and shiny metal, particularly in modern buildings. Modern buildings tend to be incredibly shiny, and that reflects insulation and sunlight, but some of that reflection will not go straight back out to space. It will actually go downwards. And I want to show you this little clip. It was quite famous at the time, but it's quite old now.
Traditional architecture you see behind me, there have been lots of ambitious skyscrapers in recent years, most of them commissioned during the property boom. You've heard of the Shard, you may have heard of the Gherkin, you may have heard of the Cheese Grater, and up here is what's become known as the Walkietalkie. 38 stories tall, costing more than £200 million. It flares outwards at the top to maximise the rent. The rent's higher in the upper floors, but that has a problem associated with it. As any Boy Scout knows, if you have a curved mirror and you concentrate the light from the sun, you can set fire to something. Now this is curved, and it's meant that the light and the heat is focused on a point down here, just below the building, and this is the sort of effect that has. You can scorch a carpet, nearly setting fire to it at this local hairdresser on Eastcheap. And have a look here on the side, the paint has bubbled up from the heat. Even the products inside the window have been affected. That's a plastic lemon. You can see the bubbles on it from the heat, from the sunlight. Now behind me is something that's become rather famous in the last couple of days, the exact spot where someone left his Jaguar just for a few hours, but because of the heat, found that when he returned, the wing mirror and various other plastic panels were melted. Now Land Securities, the owner of 20 Fenchurch Street, the Walkietalkie, has said they want this area blocked off from cars so that doesn't happen again. Not surprising when they've had to pay nearly £1,000 in damages to the
Okay, so you get the idea. That is a very extreme example, and it wasn't the end of the world, but it makes the point that some of these shiny buildings will not reflect the sunlight back out to space, but actually may reflect it downwards. So different colour surfaces and different textures of surfaces may encourage more heat. Urban areas are polluted. We're going to be talking about that later on today, and pollution is quite good at trapping heat. We don't have many plants in urban areas, and evapotranspiration is a cooling system. Because we don't have many trees and open areas and parks in urban areas, that means you don't have much of that cooling process, which of course is a nice synoptic link to the water cycle. And as you'll find out, it's less windy, and what wind is really good at doing is dispersing heat. So for a whole host of reasons, urban areas tend to be hotter. And the poster child of this is a city called Atlanta, which is in Georgia, America. And on pages 62 and 63, you've got a whole load of information about Atlanta. You do not need to learn everything about it. In fact, what I've tried to do on that slide is just summarise what the key points are, basically. Atlanta, Georgia, America, is a big city, and the city can be 6 degrees centigrade warmer than the surrounding countryside, and that is massive. And There are other cities in America who also have a significant urban heat island effect. London has an urban heat island effect. It's just that Atlanta seems to have one of the worst. So it's the one just to name drop, really. It is a big problem in America, the urban heat island effect. As you can see, 1,000 people die every year because of this. The basic reason for that is that usually, even if you live somewhere hot, at night time it cools down and your body is able to kind of recover and repair and sort itself out. If you live in an urban area with an urban heat island problem, your body is kind of under constant stress, and that can mean that people die. It generates its own thunderstorms from the convection, which is quite impressive, that essentially they've proved that some of the thunderstorms in Atlanta would not happen if it wasn't for the fact that Atlanta's urban heat island is so extreme. And it gives you some costs, it gives you some facts and figures, but it also tells you how you could fix it. And it's really, really straightforward. If we've said that one of the reasons that urban areas are hotter is because of dark coloured surfaces, guess what, ladies and gents? Put paler colours in. Paint roofs. Paint roofs white. Make tarmac slightly paler in colour. Add more plants. Have green roofs. And that's not painting a roof green. That's putting plants on a roof. Add more trees. Add more open spaces. And that's basically what we've learned from Atlanta, that we can actually fix the problem reasonably straightforwardly. There are 2 YouTube clips there. They are quite helpful for Atlanta. They go over the same kind of points. I would encourage you to watch them, but please remember this is not a massive case study. It's more of a kind of 2 to 3 bullet points, bit of a name drop that you can chuck into things. This is a super cool example, and this really is a name drop. This is real, this is not a computer generated image. This is Bosco Verticale, which translates into vertical forest. Sounds much cooler, doesn't it, in Italian? Bosco Verticale. These are residential buildings that are covered in plants. You can see lots of pale colours, you can see lots of trees and shrubs. This basically is Milan's obviously very stylish solution to the problem, and it's so brilliant that many other cities around the world are now looking to copy this to try and help to counteract the urban heat island problem. Okay, so urban areas are hotter. You need to know why that is. You need a name drop example, Atlanta, and you just need to know a couple of ways that we could fix it, which is paler coloured surfaces and more plants. That's a bit of extra information about Bosco Verticale if you want it, but it's not crucial. Right, wetter. Now this is revision, ladies and gents. I'm not going to spend too long on this because you've done this in year 1. We've also done it in year 2 once before. So as it's the 3rd time, I'm going to go reasonably quickly. You may remember that we talked about condensation nuclei, and condensation nuclei are teeny tiny little particles which encourage, I can't talk today, can I? Encourage water vapour to condense around them, and they're called condensation nuclei because they end up in the middle like a nucleus, and they make condensation happen. Condensation, it's quite a logical name. You've probably realised that in meteorology. Tropical revolving storms form in the tropics, they revolve their storms. Everything's got like a really sensible name. Now, one of the reasons it tends to rain more in cities is because pollution gives you more of these condensation nuclei, all right? The factories, the cars, the burning of stuff in fires will give you more pollution. And that is why it is wetter. And just a little example, there is a place, excuse me, in the north of England called Rochester, And they discovered, I'm going back to the Industrial Revolution now, so it's a nice little synoptic link. They discovered it didn't rain as much on Sundays. And at that time, the UK was an incredibly religious country and everything stopped on the Sabbath. So factories stopped working on Sundays. And they worked out, after a process of discovery, that because the factories were closed on a Sunday, there were fewer condensation nuclei in the atmosphere, so it didn't rain as much. How cool is that? Or how uncool, I suppose, to have discovered it. But anyway, that's why urban areas are wetter. You could also argue, because urban areas are hotter, we're going to have more convection, aren't we? And convection is going to lead to air rising, and that could also lead to clouds and rain. So, couple of reasons. Condensation nuclei probably slightly outweighs the convection, but you could talk about both. This one's the most obvious. Buildings are barriers, aren't they? If you want to sit on the beach in the UK, most people will take a windbreak with them because the UK famously is quite windy and we're very stoic about going to the beach as Brits, and we will go to the beach even in the bad weather, but you put your windbreak up to protect you. Barriers block the wind. That's kind of the point of them. Buildings behave as barriers, and that's essentially it, folks. Because we have more buildings in urban areas, there are more barriers which slow the wind down. But there's a very cool effect which really only happens if your buildings are particularly tall, i.e. it's unlikely to happen in Taunton. This is a photo, not one of my own, but this is a photograph taken in New York, and you can see what I'm talking about here. You might get this in London, but it's only going to be in the CBD. And again, little synoptic link. Remember, the reason that buildings are tall in the CBD is because that's where land is the most expensive. So what you do to maximise your return is you build up rather than outwards, because that means for the same footprint of building, you can get more back. So you build tall buildings and that creates what we call urban canyons. Like their natural counterparts except man-made. And you can also call this the Venturi effect, and it's really straightforward, folks. If the wind was blowing parallel to this street, the buildings would speed it up. It would be funneled essentially through these buildings, and actually if you were measuring the wind speed on this road, then actually it's going to be much windier than it would otherwise be. So there's a little anomaly. Generally, it is less windy, but with anomalies caused by urban canyons, or if you like it better, the Venturi effect. And I did create possibly the world's most naff bit of animation you've ever seen. So this is a city in which, of course, there are only two roads, because that's all I'm capable of, and the pale grey is just buildings. If the wind is going in this direction, you'd hardly have any wind in this street because all these buildings would be blocking it, but along here you would get the Venturi effect. Okay? Hotter, wetter, less windy. Make sure you know why. You've got some notes. Windy is on page 64. Precipitation is on page 63. Feel free to add any diagrams or notes that you need to. Right, the last thing, and I'm going to introduce this to you, and then I am going to ask you to do a little bit of independent research on this one. The other thing you have to know about urban areas is that their air quality is not very good, and I don't expect that will surprise any of you. And in the module I'm currently using, that information begins on page 65. So, what I need you first of all to do, excuse me, is to update the figures that you've got in the module booklet. I should have done that, my mistake entirely, so I do apologise, but actually you can see that the deaths are actually increasing. In the year I'm reading, it says 2 million premature deaths, and actually at the moment it's 4.2 million. This actually has really come to the forefront with COVID, because of course what bad air quality does is it affects your lung function, and that's not great in a pandemic where the virus tends to attack your lung function. So air quality is really kind of under the microscope at the moment by scientists and politicians and all sorts of people. Okay, healthcare costs and absenteeism. That's the stuff that we need to know about. Yes, it affects people and it kills people, and that's tremendously sad, and we do need to know about that. But as geographers, actually what we're slightly more interested in is the impacts of that. And it's the impact on looking after people who are poorly, and it's the impact of them not doing whatever it is they're supposed to do, be at work, be caring for their families, be going to school, and all of that kind of stuff. And that's absenteeism. So air quality is a major problem, is what I first of all need you to know. It kills people, it makes them poorly, it costs money, it is just an absolute nightmare. No need particularly to write that down, but it just gives you a sense of how bad a problem air quality is. It's one that you don't hear much about. It's one of those sort of hidden problems, if you like, unless, of course, you do suffer from asthma or you know somebody with lung problems. You'll know how debilitating that is. But for the vast majority of the population, we don't really think of air quality as being much of an issue. We are going to focus quite a lot on Asia. Another synoptic link, loads of them today. One of the things that you know from Changing Places is about the global shift. We've seen a shift of manufacturing to Asia, where it can be done more cheaply. And that has in some ways been quite lucky for us in the UK, because we don't have as many factories now. Therefore, our air quality is slightly better than it used to be. But we've transferred the problem to Asia, which is a shame. However, I don't want to give you the impression that the air quality in the UK is brilliant, because I would be lying to you. As you can see, there are some figures on the screen, which are pretty shocking, to be honest. And this is a really interesting news story, which I believe is going to start to change things. Now, this poor girl died as a result of an asthma attack, and it's been proven that every time she ended up in hospital with her asthma, it was when the air quality in her part of London was particularly bad. So they've been able to prove that with actual data. So Ella Kissy-Deborah lived 25 metres from London's South Circular Road, a notorious pollution hotspot. She experienced 3 years of seizures and hospital stays. During that time, local air pollution levels breached EU legal limits. No individual death has previously been directly linked to air pollution, and it goes on to say. So she walked to school, or was sometimes driven. And what they've been able to do, look, is to link her hospital admissions. Poor girl. I mean, it is horrible to read. Many of these coincided with record peaks in air pollution. And so this story, and obviously I'm going to give you a link to the PowerPoint and you can look at it yourself. You can also Google her. There's an awful lot of information. Why do I think that's going to change things? Because her family have been told that they may well have a case to sue the City of London. Now, if other people begin to link their poor lung health with air quality and start suing the city that they live in, that is going to make the authorities sit up and listen, because as soon as you hit them in the pocket, they start going, oh, okay, we probably ought to do something about this. So I think we're at, particularly that and COVID, I think we're at a bit of a turning point with countries and councils actually taking this seriously. Anyway, the point here is it is mainly a developing world problem, but please don't be under the impression that our air quality is great, because unfortunately that is not true. Right, the pollutants. Bottom of page 65, you should see a subheading that says smog, and underneath that there's photochemical smog, and over on page 66 there's ozone, sulfur dioxide, nitrogen oxide, fine particles and carbon monoxide. Now, I'm not expecting you to learn all of those, but if you forget all of the others, I need you to know photochemical smog. That is really important, okay? And potentially it could be a nice little diagram for you. Photochemical smog is what we call a secondary pollutant, meaning it has to be created. We have vehicles that produce nitrogen oxides and VOCs, volatile organic compounds. So they exist in car exhausts. In the presence of sunlight, there is a chemical reaction which creates brown photochemical smog. If you don't have bright sunlight, this chemical reaction does not happen, all right? And that's really important, because that basically means you're really only going to get this happening in anticyclones, high pressure systems. Because of course in low pressure you have clouds which are going to block quite a lot of the sunlight out, and you wouldn't have this chemical reaction. It means that in the UK we are quite lucky. We don't get a huge amount of this, but if you live somewhere more tropical, it might be a bit of a problem. So you can see that brownish haze. This was Mexico City, who I'm pleased to say have fixed the problem now, but that was Mexico City. And at that time, I learned about Mexico City in my A-level, and I've never forgotten these facts. At that time, birds would just drop dead as they flew through the air, because the air was so toxic, they would die in mid-flight. And they also managed to prove that just breathing the air in Mexico City was about as damaging for your lungs as smoking 20 cigarettes a day. Just breathing. So if you smoked and lived in Mexico City, I have no idea what your life expectancy would have been, but not good would be my guess. So there's just a reminder, anticyclones, air is sinking, so we don't get clouds, which is going to mean strong sunlight. That is when you're going to get your photochemical smog being created. Okay, the others, just before I talk about case studies, the others on page 66, it might be worth knowing a little bit about a couple of them. You could pick ozone, you could pick fine particles. I don't think it really matters, but photochemical smog needs to be the most important, please. And finally, this is the bit I'm going to ask you to do a bit more independently. You need to know, and I do mean small, honestly, small. I want you to have 5 mini examples of places that have air quality problems and what they are doing about them. And there are so many to choose from. In fact, I'm going to show you the next slide and you can be like, what, Nikki, that's bonkers. You don't have to open every hyperlink. It's just to give you lots of choices. Okay, so deep breath. Right. So, for example, this one is all about Transport for London and what Transport for London is doing about trying to make air quality in London better. This one, these 2 actually stories are about inventions. In fact, let's open them and show you. 4 innovations to clear the air. So, for example, Mexico City may be infamous for its smog, but it's also renowned for its murals. And now the 2 have come together in a startlingly innovative way. And so what they've done is they've created a paint, look, this is so cool, which purifies polluted air in a process similar to photosynthesis. How amazing is that? And then there's these biosolar leaves, and then there's all this other scientific stuff that's being done. So there's that. There's everything at the bottom is linked with China, which unfortunately has the worst air quality problem in the world at the moment. So there's 3 links there, excuse me, to what they're doing in China. The Guardian, this is quite a nice one. Look, they just go through really short examples of what different cities are doing. So you do not need to open every hyperlink. You just need about 5 mini examples of this is what these places are doing to tackle their air quality problems. All right, and that will be loads. So I just want to go back, sorry. AirVisual, if you're interested, this website is quite good because it's got a league table and it's constantly updated of where the worst pollution in the world is. So if you want to look at a bit of data, if you're interested in it, you can open that. Okay, so that's it for that. Any questions, as ever, you can wait till the live lesson and ask me, or you can drop me an email. Thanks, everybody.